Okay, without further ado, I'm Michael Casey, by the way, Chief Content Officer of CoinDesk. Joe Landon from Lockheed, why don't you fill us in? What is this all about?
Sure, thanks, Michael. So we're excited today to talk about Lockheed Martin and the Filecoin Foundation are working together to demonstrate Ipfs in space. The interplanetary file system is going interplanetary.
You kind of took the punchline away, but I met this bright young man when I was at MIT, Juan Benet, who came with this tremendous idea about this internet thing, and he called it the interplanetary file system. I thought, okay, why? What's it got to do with planets? And yeah.
Well, actually, from the beginning, Ipfs has been called the interplanetary file system because this was envisioned as a way to make networking in space possible. So, on today's centralized internet model, it just doesn't work in space. So imagine you're on the moon and you're surfing the web and you click something. On today's centralized internet, you have to have that data travel from Earth to space, and that's a multi-second delay if you're on the moon, or a multi-minute delay if you're on Mars or elsewhere. And so that model really just doesn't scale. So what Ipfs does is, instead of locating content on a particular server in a particular place, Ipfs looks for content based on what it is rather than where it is. So that means that if you click a particular link, it's just going to pull that content from wherever's closest to you. And so that is a model that works for networking in space in a way that the centralized internet model that we have today just doesn't work.
I want to get back to a little bit about the architecture of Ipfs in a moment, but on this space element, right, this idea that you can now act more locally, if you like, but inside space, what does it mean for Lockheed Martin? What can you do with this?
Right, it's really an enabling capability for space exploration. And at Lockheed Martin Space, we're working with NASA and other folks around the world to push human and robotic presence in the solar system farther, and to do more science, to do more exploration, and to develop more capabilities in space. And having the ability to have more efficient networking and to be able to sort of help shrink the space environment and take away some of these time delays for critical data is a really important capability for the future of building that in-space economy.
And what is the current state of it? I mean, in terms of implementations, what are you going to do? Where does things stand at this stage, Marta, and where does it go?
Yeah, absolutely. So we are in our first phase, and so we're doing a couple of things. One thing is we're identifying our first mission that makes sense for us to demonstrate Ipfs's utility in space, and we're doing that with Lockheed Martin. The other thing we're doing is we're looking at the hardware and figuring out what we need to do software-wise to make Ipfs work with this space hardware that Lockheed Martin has. And so that is the current status, and looking at many, many phases after that. But this first phase goes through beginning of September and moving on from there.
So maybe, Joe, talk us through what is possible. Like, I mean, it seems to me, space has just never been as big a conversation point. The opportunities, probably as a species doing far more in space than we've ever done.
That's right.
How does this expand the frontier in the classic sense?
Yeah, so I think having decentralized systems in space makes a lot of sense, not just because of the time delay, right? So we have, like I said before, this in-space economy. So like if you think about most of the spacecraft we put in space up to this point are doing things to help us on Earth. They're taking pictures of Earth. They're collecting data about Earth. They're communicating signals between one place on Earth and another. All those transactions, all those interactions really support and benefit Earth, and they sort of start and end on Earth. What we're seeing happen now in the space economy is that we're having space-for-space transactions. So for example, in the near future, we'll have one satellite refueling another. So that's a transaction that takes place entirely in space between two systems that really, don't have a nexus back on Earth. So the whole idea of decentralization makes a lot of sense in that context. And communications and data storage is just an essential infrastructure to start building upon.
We're building a space economy almost.
Exactly, right.
Okay. So, Marta, again, give us a little bit more detail about Ipfs. We've got a good crowd, and you've got a lot of people coming through here. There's certainly, people I think know about Filecoin, but probably fully understands the complexity of Ipfs and why it was built and what it actually, how it functions. Can you do it in a succinct way? Because it's pretty complicated.
Yeah, absolutely. So, when you think about today's internet, today's centralized internet model really doesn't scale to space. And the reason for that is, so imagine, this is a metaphor for sort of today's internet. Imagine you just read a really great book in physical hard copy, and you want to tell a friend that they should read that book. But you don't tell them the name of the book. What you do is you say, well, you see, this book is at the New York Public Library, second floor, third shelf from the right, 3 books over. And they're going to have to fly to New York, go to the public library, go to that shelf, and hope that that book is still there, right? But what if someone moved that book? Or what if there were books, copies of that same book that were much closer to them? What if they had that book in their backpack the whole time? What if someone ripped out a page? So again, that's today's internet. Today, when you are going to a link, you are going to a particular place on a particular server. And that just doesn't make sense, especially when you're talking about space. What makes way more sense is to just tell your friend the name of that book and let them figure out what's the closest and easiest way for them to be able to read that book. And that's what IPFS does. So instead of identifying content by where it is, IPFS identifies content by what it is, using content addressing. So each piece of content has a particular address that's a hash. And what that means is, if you put in that content address, instead of going to a particular server in a particular place, you're going to pull that content from wherever's closest to you. And so that is what IPFS does, and why it's so powerful, why it's called the interplanetary file system.
Yeah, so if I could just bring that example back to space. So instead of a book in the New York Public Library, what if it's a critical procedure for an astronaut on the Orion spacecraft on their way to Mars, right? What if I need to have that procedure right away? And going all the way back to Earth looking for it is going to take 12 minutes in some cases if you're at Mars. But what if instead it's on a server on the moon, or on a server already on the surface of Mars? You can get to it much quicker. This particular example would improve the safety of those astronauts. So it's a critical capability for us to have.
I'm definitely going to use that book analogy. That's the best explanation of IPFS I've seen. I have not heard that. The book, that's great. Here's the book, go find it. Joe, to you again though, like when you and I chatted a bit last night, we went to where my head often goes when I start talking about crypto and blockchain and space, and that is like, ooh, space doesn't have the same jurisdictional regulatory environment. When you talk about this space economy evolving in that place, whose currency are you using, or in what regulation are you actually, bound by in terms of the rule set and so
right,
forth?
So
is that a factor in all of this?
Yeah, absolutely, and it's you raise really good questions. There aren't answers to all of those questions yet. There is some policy framework in place, like the Outer Space Treaty of 1967 talks about who owns what and who sent it to space matters. So I think there's a lot of questions that we'll raise in the future, and we'll have to answer them. But I do think those questions get even harder if you have transactions happening from space to space where there isn't that tie back to some place or country or person on Earth.
Okay. Marta, last word. I know you're excited about this, so you're allowed to actually exude that excitement and give us more if there's something else you'd like to add.
Yeah, we've been working on this for a really long time, and I really just want to say a huge thank you to so many people who have made it possible to get to this point. This has been a really long time in the making. There are some phenomenal people at the Filecoin Foundation who have just worked so hard with Joe's team at Lockheed Martin. And I just want to say a huge thank you also to Joe and Lockheed Martin. Thank you so much for making this possible.
Yeah, we're excited to work on it too.
But you still can't be close to each other because you are going to be the intermediary in this process. Alrighty, listen, first of all, you guys met in 2018 at, where was it again?
We met at Consensus.
Shameless, very silly way to get a plug in here. Those of you who don't know, CoinDesk, that's us. We put on the biggest, most important conference in the blockchain crypto space, and it will be on in 2 weeks' time, June 9th to 12th. And we got thousands and thousands of people and hundreds of speakers and 15 stages. And it is, it's the most important networking event in the blockchain calendar. It's because it's 2015 and incredible moments like this happen there. So be there or be square.
Yes, thank you.
Great.
Also, thank you to CoinDesk for hosting Consensus, where Joe and I met and started talking about these issues. So thank you, Michael, and CoinDesk as well.
You're most welcome. All right, I think that's it. That's all we have time, right? So thank you very much. Congratulations, guys.
Thank you all. Thank you.